All right, AP Calculus. We are on final exam number 1 review for Wednesday. This was the calculator problem of the thing that I forgot to give you, so there we are. I'm going to call this thing key because there is currently no key for this one. Okay, so this one is a calculator problem, which means we're doing problem 1 or 2. Ben and arrow, calculador. There we go. Make sure that those are the ones with batteries. They were on top, so I'm assuming they have batteries. I will also open up my calculator here as well. Open recent TI-83. All right, so coming back over here, a particle moves along the x-axis. So its velocity is this thing. Velocity is natural log of t squared minus 3t plus 3. And I know the start position. The start position is 8 when time is 0. All right, I'm looking for acceleration. Acceleration of t is what? Derivative, integral, something?
Derivative of v.
Yep, it's equal to v prime of t. So what is v prime of t? Anyone know how to take natural log derivative?
So it'd be 1 over, well at first it's basically 1 over x t squared minus
No,
3, and then you have to do derivative.
You don't actually have to do the derivative though, because you can do it on the calculator.
Oh. Yeah.
Actually, yeah, why are we writing this out? We were about to take the derivative. Let's just plug it into the calculator. I forgot that we were dealing with a calculator problem. Thank you, Ben. Let's enter it into our y function. So y1 is equal to the natural logarithm of x squared minus 3x plus 3. You don't need to end the parentheses, but I will. All right, then I'm going to quit out of that once I have it all entered, and I'm going to do math. I think it.
How do you quit out of the
Second mode, I guess. Yeah.
got it.
And then I'm going to go math, and I believe it's 8. Math 8 is the derivative, and that's what we're doing. So math 8. I'm taking the derivative of y1. So derivative of var's right, enter 1. Derivative of y1, comma, with respect to x, comma, at what point? At 4. 4. Enter. Chunk. There it is. So again, this is an approximation rounding to 3 decimals, so I'm going to say approximately 0.714. Approximately 0.714. You do want to be writing that it's v prime. I think you probably get a point for that. Very commonly, you will get a point just for writing v prime.
Can I be like a of t equals v prime of t equals v prime of 4?
Well, it's not equal to v prime of 4. Then separately, I guess technically what we should be writing is this stuff is separately. Now that we know that a of t is equal to v prime of t, we should say now v prime of 4 is equal to 0.714. That's how we should properly be writing it. On to part B. Find all t in the open interval 0 to t to 5 in which the particle changes direction. What does that mean, change direction?
When the slope goes from positive to negative or negative to positive.
Yeah, so what is slope?
G prime sign change?
In terms of, is it position, velocity, or acceleration?
Oh, it's acceleration.
It's velocity, yeah. So
I thought velocity was high.
So in general, you have 3 things. You have position, velocity, and acceleration. Velocity is the first derivative of position. So let's think about Mr. Sandell's position, right? Mr. Sandell's position changes, but what you're really thinking about is my speed. Once my speed hits 0 and then changes to a negative, that means I've changed direction. So we're saying, where does my velocity go from a positive to a negative, or from a negative to a positive, which is exactly what you were saying.
So what's acceleration?
Acceleration is how fast I'm increasing. I'm running into the wall, and then I slow down, and then I start changing direction.
So like the rate?
So it's the rate of the velocity, yeah. Yeah, that's a great review. Okay, so what we're looking for is we're looking for v prime sign change. So,
it's just v sign change.
oh, why did I say v prime? Yeah, you're right. I was thinking f prime sign change, v sign change. Thank you, Ben. All right. So there's 2 parts to this question. First, find all of the changing direction, which is v sign change. Then we're going to do the second part, which is finding where the particle is traveling only to the left. And finding the v sign change is going to be important for doing that second part of the question. So v sign change, how do I do that?
You plug it on the calculator.
Yeah, I mean, you can just look at the calculator, right? So on the calculator, let's go to window. What should our window be? 0 to 5. 0 to 5, and then to zoom to that window, I'm going to do zoom 0.
It's definitely velocity and not position, because you think if position was negative, then the particle's moving backwards.
I guess you could look at you could find it by the graph of position, but the problem is they didn't give you the graph of position or the equation for
for
it.
the graph of velocity, are we looking for zeros or are we looking for touches x?
Great question. Let's turn that over to everyone else. In terms of this calculator, am I looking at this bottommost point or where it crosses the x-axis?
When it crosses x-axis?
Because that means that the velocity has gone from a positive to a negative. So I have to find those x-intercepts. So I have to calculate that. So second calc or second trace, and I have to find that x-intercept. So I'm looking for those zeros. So hit 2, my left bound, I'm going to say like 0, my right bound, maybe 1.5, and I'm going to say 1. I got a 0 exactly at x equals 1. All right, so write them down. There's a v sign change at, it's not x, it's t, I guess. T equals 1, and there's another one over here. So if I do same thing, second trace, 2. On my left bound, I'm going to do 1.5 to 3. I'm going to guess maybe 1. I'm going to guess 2. And it is 2. Haha! Good guess, Mr. Snell.
Hey, everybody, it's 2.
Yeah. Okay, so that was the first part of the question. Second part of the question, during which intervals is a particle traveling to the left? So now I'm going to make that number line, and these are like our critical values, I guess. So I'm going to plot those critical values, 1 and 2, and I'm going to choose nice numbers. What's the nicest number?
Let's do 0.
Let's choose,
Oh, wait.
yeah, 0 is good. And I think, are there any domain restrictions? There might be domain restrictions. So, well, technically it is 0 to 5, yeah. So maybe I can't even plug in 0. But when I plug in 0, you can look at the height of the graph. Is the height positive or is the height negative? Positive. So just coming back over here, that is clearly a positive. And looking at the graph, that's clearly a negative, clearly a positive height for the velocity, which means the velocity is negative or traveling to the left between
1 and 2.
1 and 2.
Yeah, 1 and 2. 1 and 2, negative. Negative means left. So our answer here.
Say that it was, say from 1, it goes from positive to negative. But at 2, it goes from negative to negative. So would that mean that the v sign change at t would be equal to 1?
Say that one more time.
So say that, okay, so you know how at 1, it goes from positive to negative?
Yes.
What if at 2, it goes from negative to negative? Would that mean that the answer would be the v sign changes at t equals 1?
Yeah, just t equals 1, and then the particle travels to the left from 1 to infinity.
Okay.
Yep. So particle travels left, travels to the left, on 1 to 2. Cool, and that is all of part B. Let's go on to part C. Find the position of the time or the particle at time equals 2. How am I going to do that?
Wait, I have a question.
Yes.
Why wouldn't it be from infinity to 1 and then 1 to 2 and then 2 to infinity?
I'm only looking for left, which means I'm only looking for the negative.
Oh.
Negative means left.
Alright.
All right, and then finally, find the position of the particle at time equals 2. So how do I get to position from velocity? I do what?
Antiderivative?
Integral, antiderivative, exactly. So I'm going to take the antiderivative, and that's only going to be the change, right? Because our full equation is to get to the end value that we're looking for. End is equal to start plus change. So the thing that we're going to look for is start. What was our start?
Our start was 4. Oh no. At 8.
Yep, our start is 8. So coming down here, I'm going to do 8 plus the change, and the change is, as we all said, integral or antiderivative between where and where?
0 and 2.
0 and 2. This 0 bottom boundary came from this 0, and 2 came from this 2. So 0 to 2 of that velocity. I'm just going to write vt because I'm lazy. Vt dt. You could all write out the natural log of t squared minus 3t plus 3, and that's just kind of a waste of time at this point because we already have this in our calculator. Second mode to quit out of this, and we're going to do 8 plus, and then we're going to do the integral. So that's going to be math 9, the integral of our y1 function. So vars right, enter 1, y1 with respect to x from 0 to 2, hit enter, and you'll get our final answer as 8.369. This is approximately 8.369. And do we have any units on here? Nope, no units. So there is our final answer. Questions about part C? No? Okay, and then on to part D. Find the average velocity. Ooh, what is the definition of average of anything? Average of box is equal to what?
The total over the time interval?
Yep. So it's going to be total, I guess total change, if we want to maybe say total change over total time. Which mathematically means we're going to do 1 over b minus a integral from a to b of box. Whatever we're looking for. So
It's sad to know that I forgot about this.
no, it's fine. I mean, it was a lot of material, but now that we're doing the review, we will know it going into the next final.
Wait, why is it 1 over b minus a? Why isn't it like f of b minus
So it's the average.
So this b minus a on the bottom comes from time. The time was b minus a. I mean, the time went from a to b, so the total time is b minus a, and I'm going to divide by that.
So the 1 should have come from total change, right?
This one is just saying there needs to be a placeholder on the top.
Oh, yeah, I got it.
I guess another way of saying that is getting rid of this and just saying all over b minus a.
Okay.
Yeah, so, and notice that average of anything is equal to blah, blah, blah of anything. This anything, this box and box are the same box. So if I'm looking for average velocity, velocity is going in this box. So we'll write down average velocity will be equal to 1 over, what are my b and a?
0 and 2.
Yep, so my 0 is a, my b is 2, so it's going to be 2 minus 0 integral from 0 to 2 of velocity, vt dt. And that is going to be approximated because we're going to have to round that, and I have to enter this all in my calculator. Well, I already have 0 to 2. 0 to 2, that integral was 8.369. I just need to divide that by 2 and I'm done. So come back here, answer, divide by 2, done. 4.184.
Wait, 8.369 isn't the integral? That's the...
Oh shoot, yeah, it's 0.369. So I have to go backwards.
Oh.
Second entry, hit that again. Oh, and I'll hit enter and subtract 8.
Wait, so it's 0.714 that we need to use?
So it's 0.368 is that integral. This integral is 0.368.
Oh.
This guy right here is 0.368. So we're really taking 0.368 divided by 2. So let me grab that, delete you, and thank you, Ben, for always catching my mistakes.
Isn't it 0.369?
Or yeah, 0.369 divided by 2. I'm not going to round, and now I'm going to round. So 0.184. 0.184. I'll come back and grab Rochelle's error that she caught. I mean, Ben, every single time you're catching a mistake, which is a lot now,
Wait.
you should be logging this.
I got 0.1845, so we're going to be 0.185.
Did you do 0.369 or did you do answer divided by 2?
Oh,
So I never rounded until the very end.
okay.
Yeah, I'm pretty sure 0.185 will not give you points because you rounded too early.
That's annoying.
It is.
Calculator will do it automatically.
Well, it's just the fact that like I put
Even if the calculator is rounding automatically to 3 decimal places, it still stores this value to all decimal places. So as long as you did answer divided by 2, it should still give you 0.184. All right, and there is our final answer. So I think Ben got like 2 or 3 extra credit points there. Rochelle got that extra credit point for the rounding to the 9. If you're logging those do bring up our grade. All right, second half of the first page. I'm on the second side here. I'm doing the antiderivative. It's a definite integral, so I have to not only take the antiderivative. It's unclear whether or not I should be using a calculator. Looking. None of these need a calculator, so assume no calculator for this. No calc. Or if you can somehow draw a cool little calculator symbol, it has a screen up here, it has buttons. Then you can do a circle around that with a slash. No? Am I the only one that's going to draw the calculator? All right, anyway, antiderivative of sine is it positive or negative cosine?
negative cosine.
Yep, negative cosine because anti-same, S for same, anti-same is change the sign. So it's negative cosine of x evaluated between 0 and pi over 4. So now I need to plug in pi over 4 and 0 into cosine of x. What is cosine of pi over 4? That one's kind of a tricky one. Does anyone remember from pre-calc?
Would it be?
It gotta be the 2.
It has to be.
'cause
Oh,
look at all the
it's the
answers.
square root of 2 over 2, but it's negative because of cosine. Negative cosine.
Yeah, so I'm going to leave that negative from this negative right here out front, and I'll deal with that at the very end. I'm just going to deal with the cosine on the inside. So on the inside, I'm going to have now cosine of 0. What is cosine of 0? Is that 1 or 0?
It's 1.
It is 1. So, and then I guess distribute the negative. I guess we could have done that at the very beginning. I have a negative square root of 2 over 2 plus 1. Correct answer, D. I guess the giveaway on what cosine of pi over 4 is looking at the multiple choice answers. There's a lot of square root of 2's over 2's in there.
But if you distribute the negative, wouldn't it be a negative one?
No.
Oh, where?
So I'm subtracting because of the bounds. So that's why I got to subtract 1, and then I'll deal with the negative now.
Oh, okay, got it. Yeah.
Yeah, that's always a good distinction to make. All right, any other questions on number 5 before we move on to number 8? These correspond to the numbers on your final number 1. All right. Oh no, I have 2 x's. That's product rule, but going backwards product rule is technically using integration by parts, but there is an easy way to do this. Integration by parts is BC calc. AB calc means we're using taxman. Yeah, there it is. So U, taxman, and U prime. Setting it up. All right, what should our U be?
Cosine? No, it's x to the third, right?
Yeah, look for the most complex thing, and then do the inner of that. All right.
Tax is x to the power of 2.
Good, and U prime.
3x squared.
That means we're going to pay taxman with
1 over 3.
3. Yep, there it is. So now my new integral after I pay the taxman was x squared. This x squared is now turning into a 1/3. It's going to be cosine of x to the power of 3. Now I can actually take the antiderivative. So the antiderivative of cosine, we already told this before, is positive sine of x. Can't write x to the power of 3. All of that still 1/3 out front. Don't forget your plus c. And does anything look like this? It's going to be positive.
D?
It
No,
looks like b. Is that right?
Yeah.
Cool. There it is, b.
Wait, I have a question.
Yes.
Why wouldn't you do, since we took the derivative, antiderivative,
Yes.
why wouldn't we multiply the 1/3 sine of x to the third times it by x to the second?
X to the
Like
second.
dinner.
So dinner is taxman. Taxman encompasses dinner.
Oh.
Yeah, so it makes it so that the integral is super easy if you use taxman. Otherwise, you'd have to use U substitution, and then, Rochelle, yes, you'd have to do all of that.
It's kind of like we already did dinner and daughter.
Exactly, yeah. Taxman is a method of getting I guess it technically is dinner, even though we're going backwards, because you have to figure out what the derivative is, even when you're doing U substitution. Yeah. All right. Other questions? Nope. Okay, on to number 9. And as Ben is waiting, think about what a 6-sided shape would roll like. Does it just wobble back and forth? Because it kind of does, but it kind of doesn't.
They also roll way better on paper.
Yeah.
as opposed to-
Is it because paper has more friction than wood?
Probably.
Or a higher coefficient of
Or more
friction, I guess, if
friction
you're...
in this, like plastic coating on the wood.
Yeah, I wonder if it would roll better or worse on the carpet
Oh,
than paper.
okay.
Carpet has really
Try
good
that.
friction. I bet if we had like a rubber mat, like this is plastic.
We kinda have a rubber
What if
mat.
we use the
wood
binder?
Oh,
We already
yeah.
rolled it on that, and it didn't work because I angle.
It's not working very well.
Okay, good to know. All right, number 9.
Anyway,
I have to take the derivative. So, and I have to take it by hand this time. So this time I am actually writing 1 divided by all of the inner. 1 divided by x plus 4 plus e to the negative 3x. That is going to be times what?
To the 1 plus e to the negative 3x squared. I mean, negative x.
1 plus e to the negative 3x times what?
Times 3, negative 3.
Times negative 3. And I ran out of room there. Let me, grab you, move you away. That times negative 3. Put the parenthesis right there. Yeah, so negative 3 came from dinner. The inner was negative 3x. Dinner is negative 3. And then we have to plug in 0. Let's plug in 0 right away without simplifying. Otherwise, we're going to have to do too much work. That's 0. This is 0. This is e to the power of 0. So e to the power of 0 is 1. So I have 0 plus 4 plus 1 there. And then this is going to be 1 plus 1 times negative 3.
So it's
wait, you only multiply the last one by negative 3? Or is
Well, this
you also
this whole thing
multiply-
is one thing, one unit, because that was Dowder times dinner.
How come you don't multiply
oh, so
the
it's
one
negative
by-
2.
This one didn't have a dinner. This one is just 1.
It's like using the PIMDAs or how you ever say it.
Yeah, it is using PEMDAS, but the question still remains, was I multiplying this entire thing by negative 3 or just the e to the negative 3x by negative 3?
Just because it was dinner in it.
Yeah, so whenever you're doing dinner and derivatives, only the thing that I'm talking about for the dinner, so it's Dowder times dinner. This was a different derivative, so it's a different function. Yeah, so this is going to be 5 out here times 1 times negative 3 is negative 3. Negative 3 plus 1 is negative 2. 5 times negative 2, uh-oh. Oh, this is a this is a fraction. It's 1 over 5 times negative 2. And 1/5 times negative 2 is negative 2/5. Easy peasy lemon squeezy. I said that with a straight face. On to number 10. Oh boy. So, f of x, what is f of x? Height, slope, or concavity?
Height.
This guy is height. F prime of x is,
Slope.
and f double prime of x is concavity. All of those are negative. So it's concave down. Slope is negative. Height is negative. So let's automatically eliminate all the things that have a positive height. Not e. Oh, you already know?
No.
Oh.
But I want to make a joke.
Okay.
I bet you f double prime of x has a cavity.
Yeah, it probably
It needs to go
does.
to the dentist.
It needs to go to the dentist. That's probably a better joke, dentist, because it has a cavity. Yeah. Let's now eliminate all the things that have positive slopes. It doesn't matter if it's positive and negative. If they have any positive slopes at all, get rid of them. Does A have a positive slope?
No. Yes.
Yeah, right there. There's a positive slope, so get rid of A. Does B have a positive slope? Nope, so it's still good. Does C have a positive slope?
Yes.
Yes, get rid of it. Does D have a positive slope?
No.
No, so it's between B and D. Now, let's compare concavity. All of them should only be concave down.
So it's B.
So it's
Yeah.
B. D is concave up right here.
Well, it's both, but still.
All right, that is it for the video. You are doing the next page, front and back, all on your own. I'm going to be working on the key in front of you. Are there any questions on that first page, front or back? All right, good luck.